Moving into our second process of urine formation, tubular reabsorption. Now, in the case of tubular reabsorption, this is when items are going from the renal tubules into the blood. So they've already gone through filtration, they've gone through the glomerulus, gone into the renal tubules, they're now going back from the renal tubules into the blood. This is a select transepithelial process because you're going across the epithelial membrane, looking at all organic nutrients are crossing, as well as water and ions being reabsorbed with hormonal regulation. So think about endocrine. What hormones are helping to regulate water and how is that working? That's part of the process here. Now, these are both active and passive processes. It partially depends which ion you're looking at, which molecule you're looking at, but also what part of the tubule are you in? Are you in the proximal convoluted tubule, loop of Henle, distal convoluted tubule, or collecting duct? So it has some variation depending on where location and what ion it is. Let's start with sodium. Sodium probably can be arguably one of the most important ones here because sodium is a primary active transport. That means you're putting energy into it. And this is through the sodium-potassium ATPase. Now, this movement of sodium is really important because it really provides the energy for the movement of almost every other molecule across the membrane. They'll be pulled with sodium, they'll go as an antipore against it, but they're going to be looking at the actual sodium movement to control it. So now, water itself. We know water is moving across because that's a huge amount of the plasma. But you need to reabsorb that water back into the blood because you don't want to excrete that much water. So water is reabsorbed through osmosis primarily. Basically, the water needs to go back because it's trying to dilute out what's in the blood. Now, aquaporins can help and aid a little bit here, but really most of it is based on the actual water going through osmosis. Now, cations and fat-soluble substances, they're usually followed by diffusion, simply just diffusing right through the membrane. So a little more movement of water, a little movement of these cations, these fat-soluble components as well. Now, this is trying to show one nephron and being symbolic of what's being moved across each component. So for example, up top here, that is the proximal convoluted tubule. You'll notice that the arrow here pointing out is trying to show you what is leaving the proximal convoluted tubule. That means what is through the tubular reabsorption. Now that reabsorption is going back into the blood, going back into the capillaries. And there's quite a few things here, from glucose, amino acids, proteins, vitamins, lactate, urea, uric acid, as well as all the different components here, from sodium, potassium, calcium, magnesium, chloride, bicarbonate, water. All of that is being reabsorbed back into the bloodstream. But that's just in the proximal convoluted tubule. In the loop of Henle, specifically the descending loop of Henle, you have water moving. Water's being reabsorbed out of the descending loop of Henle. But then the ascending loop of Henle is reabsorption of sodium and chloride, potassium. Think salts. Now that movement of water being reabsorbed out of the descending loop and the ascending loop being salts, that's to come back to play a part in dealing with concentration of urine. So keep that in the back of your mind. We still have to get to that. But then let's go up to the distal convoluted tubule. You'll notice we have sodium, chloride, bicarbonates, water, all being reabsorbed again, going back into the blood. And even the collecting duct can have water and urea being reabsorbed. Now that's not always happening. It depends on what's going on in the system. That can be turned on and off or increased and decreased. But that's just the reabsorption. We haven't even gotten into the secretion aspect yet. These are showing secretions, things that are going back into the renal tubules from the blood. You can see how in the proximal convoluted tubule, urea, uric acid, creatine, some drugs are doing this, hydrogen ions, all this is going back into the filtrate. Where over here in the distal convoluted tubule, hydrogen ions, potassium ions, they're all heading back in, NH4. So it's all depending on, is it being reabsorbed, that's what's in the purple here, or secreted out of the blood and into the filtrate, what's more in the tan color. All right, the next couple slides are to go individual piece by piece, showing where they're working and what's happening. So for example, looking at glucose to start with. Proximal convoluted tubule, 100% almost is absorbed. So reabsorption of glucose, almost 100% proximal convoluted tubule. Nothing else the rest of the way through. It's all been pulled out. Oligopeptides, amino acids, proteins, almost 100% proximal convoluted tubule. Again, they're pulling them all right out right away. Move down to vitamins, lactate, creatine. Those are again in the proximal convoluted tubule. Vitamins and lactate reabsorbed, but creatine is secreted, but it's still dealing with the proximal convoluted tubule. So if you notice, there's a lot of things happening in that proximal convoluted tubule. Urea spread out across a few here. About half of it is the proximal convoluted tubule, but look at the loop of Henle and collecting ducts. You have a mixture of secretion and reabsorption here. So there's still, depending on concentration of urine or not concentrated urine, it's going to depend on how much and where it's being pulled from. Sodium. Now, in case of sodium, we're looking at give or take about 2/3 in the proximal convoluted tubule. But then the other three parts, loop of Henle, distal convoluted tubule, even the collecting ducts, are all still working with sodium to make sure everything's balanced properly. Because remember, sodium sets up a lot of the other movement of ions. Chloride. Looking at reabsorption in the proximal convoluted tubule, reabsorption loop of Henle, reabsorption in distal convoluted, reabsorption collecting. All depends on where you need it and how much needs to be pulled. So the actual system constantly can regulate chloride all throughout the entire process. Water. 2/3 of that is proximal convoluted tubule reabsorption. That's really where you pull most of it. But you can also be pulling out a chunk of it in the descending limb of the loop of Henle. Now that will be helping set up more concentration of urine, which we still have to talk about more later. But that's why the loop of Henle needs so much water still to be pulled out and moved back and forth. It's helping to concentrate as you go further and further down that renal pyramid. So looking at some different ions, some different components, how things are moving, reabsorption and secretion a little bit in the tubules.